Hey guys, today we're going to kick off working with cones and spheres. I'm going to tell you right now that a couple things in your packet got out of order. That's my fault. I'm sorry about that. I do believe cones are your next one in line, but then I accidentally put pyramids and then spheres. We're actually going to do cones and spheres today because they're both fairly easy, and then we're going to do pyramids tomorrow because those ones are a little bit trickier. Okay, so you may have to kind of rearrange in your notes here a little bit. You've got it all there. It's just I accidentally put a couple things in the wrong order, I've noticed this morning. Okay, so what we're going to look at today are cones. So cones are like a pyramid, okay, if you think of pyramids, except they have circle bases. You can think of like your traditional, or like some ice cream cones, okay, are shaped this way as well. Okay, so when we're working with cones, there's really three big pieces that we need to be aware of. Okay, the first one is the slant height. Okay, this is new to us. We didn't have a slant height when we were working with prisms and cylinders. Okay, slant height is if you would actually go down the side. Okay, it's slanted, which is why it's called slant height. And what we use is we use an L to represent slant height. Okay, and we're going to be using that in our formulas today. The other thing you need is you need the regular height, which will go directly right down the middle of your cone. And then you need the radius. Okay, now the good news is the height, the radius, and the slant height will always make a right triangle. Okay, and for that right triangle, we will always be using the Pythagorean theorem. Okay, so you will always know two of the sides looking for the third one to finish off the problem. Okay, so that's kind of the three pieces we need whenever we're working with cones. Okay, so we're still going to be finding lateral area, surface area, and volume. Formulas are going to be a little bit different because, again, it's not a cylinder anymore. Okay, so the first formula for LA is going to be 1/2 the circumference of the base times the slant height. Okay, for surface area, it's still going to be your LA plus, now this time we only have one base, we don't have two bases. So it'll be just a capital B. So this would again be area of the base. Okay, but we don't have a 2 in front of it like we did before because we don't have two bases anymore. And then volume is going to be 1/3 area of base times height. So this whole cone can hold 1/3 of what a cylinder would hold, okay, with the same circle base. Okay, so these are the three formulas we're going to be using today for cones. All right, so let's go ahead and jump right into some examples then. All right, so first one says you have a cone with a radius of 5 meters and a slant height of 13. Okay, so radius of 5, slant height of 13. Okay, so again, we have to have these three pieces, so you might as well find the height right off the bat because you're going to need it. Okay, so 13 would be the hypotenuse. The slant height will always be the hypotenuse. Okay, so it would be 5 squared plus your x squared, which is our height, equals 13 squared. Now, if you recognize that is a Pythagorean triple, again, can save you a little time. You're going to end up getting 12 for the height. Okay, so once you have those three pieces, then we can go ahead and start plugging in our stuff. Okay, so first one, 1/2 of circumference. Remember, circumference is 2 pi r. Okay, so if my radius is 5, 5 times 2 is 10, so I get 10 pi for my circumference. Okay, slant height, again, is the one that goes down the side. That would be my 13. Okay, you multiply those together and you'll end up with 65 pi for that one. Again, don't worry about labels. I actually prefer you don't have them because it kind of messes up the Google Forms. Next one, you take your LA plus B. So my LA is 65 pi. Area of base, it's a circle, so it's pi r squared. Okay, so if 5 is my radius, 5 squared is 25. Now, because they do both have pi's, we are allowed to add those two together, so we'd end up with 90 pi as the surface area or total area. Again, surface area and total area are the same thing. Lastly, for volume, so area of base, that's the same as what I found right here, so it'd still be 25 pi times regular height. Remember, regular height is the one that goes directly down the middle. That would be 12. You don't use the same one. Okay, you did before, you don't anymore. Okay, so you'd go ahead and multiply those together and you would end up with 100 pi. Okay. And essentially that's how we work with cones. We'll do one more here, but it's kind of the same for every one because a circle is always your base. Okay, when we get into pyramids, that's when our bases change. Okay, that's why those ones will require us to look at a little bit more. All right, so for the next one, they give us a diameter of 12. Okay, so if diameter is 12, that means radius is 6, and they give us a height of 9. Okay, so first thing we probably want to do is find that slant height because we're going to need it. Okay, so it would be 6 squared plus 9 squared equals your slant height squared. Okay, that one is not a Pythagorean triple. Okay, if you go through and you simplify it, you will get 3 square root of 13. Okay, once you have that, you then have everything you need. Okay, so LA would be our 1/2 circumference times slant height. Okay, so for circumference, if 6 is my radius, times 2 would be 12 pi for my circumference, times my slant height, which is my 3 square root of 13. Now again, just be careful when you multiply this. I can multiply the 1/2, the 12, and the 3 together, which will give me 18. And then we'll just attach the pi and the square root of 13. Okay, do not want to put those ones in the calculator. So surface area is your LA plus B. So our LA is from up above. Oops. Area of base or radius is 6. 6 squared is 36, so it would be 36 pi. Because of that square root of 13, I cannot add those together, so I just have to leave it like that. That's my answer. And lastly, for volume, area of base is going to be our 36 pi. Remember, this is the regular height, which would be your 9. Okay, you'd multiply those and you'd end up with 108 pi. Okay. So that's how we work with cones. Again, just need slant height, radius, and regular height. If you have that, you'll be good to go with cones. Okay, one last problem where we're just going to work backwards. It says if the volume of a cone is 72 pi and the height is 6 feet, find the radius. Okay, so we're dealing with volume here. Okay, so it tells you the volume is 72 pi. We're looking for the radius, so that means we'll just have to use the formula here, which is pi r squared, and then times the height, which is 6. Okay, so if I combine my numbers together, 1/3 times 6 gives me 2. So I can divide by the 2 pi, which will give us 36. And then take the square root, and you'll get the radius to be 6. Okay, so again, if we're given, one of the volumes, the surface area, the lateral area, we can always work backwards to find a different piece that we might need. All right? So that wraps up cones for us. Okay, next we're going to go on to spheres, but I'm going to do that on the second video. Again, skip pyramids. We'll come back to those tomorrow. Jump ahead to the spheres.